Hello everyone, we'll be discussing inverse functions in this video. Well, what does the word inverse mean? The word inverse basically means to invert. You can think of it, um, as if you're turning something upside down or turning something inside out. Reversing something is another similar thing. Okay, so let's take a look. Let's think about what functions really do, and then we'll discuss the idea of an inverse of a function. So let's start with a pretty straightforward function. Let's say we've got a function which is f of x equals 2x plus 5. Okay, and so if I take, let's say, f of 2, we'll get 2 times 2 plus 5, which is 9. And if I take f of 3, we'll get 2 times 3 plus 5, which is 6 plus 5, which gives us 11. Now let's think about it in a little bit more of an abstract sense. So there's a set of things that I can input into this function. What's that called? It's the domain. So um, this is our domain. Okay, and we have 2 over here and we have 3 over here, and pretty much you can input any value into this, but I've drawn contained sets just to help you visualize it. Now when we apply the function, let's think about what it means to take f of 2. We are inputting a number 2, and then the function is outputting the number 9. It is mapping us from 2 to 9. It is mapping us from 2 to 9. Okay, this is mapping, and when we take 3 as our input, it is mapping us to 11, right? So if I take the number 2 from our domain, I input into the function, and we're getting mapped to the number 9, and it is being done by the function. The function is doing that mapping. Now this raises an interesting question: is there a way to get back from 9 to our 2? Okay, and is there a way to get back from 11 to 3? Now, is there some function that takes us, that brings us from this was the range, from the range back to the domain? That function is called the inverse function of f. Okay, so um, the function takes us from 2 to 9, and the inverse will take us back from 9 to 2. Let's say that y equals 2x plus 5. Let's just take this function. You give me an x, it'll give me a y, but we want to go the other way around. We want to give you a y and we want to get an x. Okay, so this was our function. We had f of x equals, or y equals 2x plus 5. Now we want to give a y into the equation, and we want to get an x. Now how are we going to do that? Now literally all we have to do is to solve for x in terms of y. Y equals 2x plus 5. Now I'm going to solve this for x. If we subtract 5 on both sides, we'll get 2. Y minus 5 equals 2x. Now we're going to divide both sides by 2, so we get this. Okay, and this is literally our inverse function. Now let's try inputting our 9 into this function. If I input, because we're gonna input this number, this is our input. Now the range is now the domain. The range is now the domain for the inverse function. For inverse functions, the range, the domain of the function is the range of the inverse of that function, right? And similarly, the range of the inverse function is the domain of the normal function. We'll discuss more about that in a moment, but for now we've got this inverse function, which is x equals y by 2 minus 5 over 2. Now what we are going to do is this x, which is equal to f inverse of y, right? Because what we did was y was equal to f of x, right? And when we took the inverse of y, what's going to happen is f inverse and f of x, these two are going to cancel out. And why do they cancel out? You'll understand this when we learn composite functions in another video. But f inverse of y is going to be equal to x, and so x equals y over 2 minus 5 over 2, which is equal to f inverse of y. Now what we're going to do is, what the examiner wants from us is to give the answer in terms of x. So what we're literally gonna swap the y for the x. Okay, we're gonna input x into our equation, and this is our inverse function. And yes, the function notation, let me give you the function notation. This is our normal function. Our inverse function is going to look like this: f with a negative 1 up there, as if it were the power. Now I'm saying as if because it is not equal to this. Please don't write it like this. This is not equal to this. This, the way we read it, is f inverse of x, which literally means the inverse of the function f. Okay, the inverse of this is f inverse of x now. Okay, so now the steps for taking the inverse of a function is, all you have to do is literally solve for x. Then you get this equation: f inverse of y is going to be equal to some equation, and then you're going to swap the y for the x, and that's how you take the inverse of a function. Okay, let's take a look at this graph right here. It's the graph of we've got a function which is f of x equals the function that we took. What was the function that we took here? It was 2x plus 5. So we've taken this function and we've taken the inverse of this function, which is x over 2 minus 5 over 2. Okay, now as you guys can look on this graph, this is our f inverse of x, and this is f of x, and it has a line of symmetry. A line of symmetry, when you graph a function and its inverse, a line of symmetry always exists, and that line of symmetry is going to be the line y equals x. And why is that? Because what did I tell you in the start? We're gonna solve for x, right? Now what happens is, on the graph f of x, we've got a point which is, if you input x right here, you'll get the output which is 5. Okay, and you can input x as 0 over here to get 0 plus 5, which is 5. So you have the point 0. Let me use another color. You have the point 0 comma 5 on f of x, right? You have this point on f of x, and for the inverse you've got this point. Okay, this is 5 comma 0, because if you input 5 into this, what you're gonna get is, let's input 5 into this. So you got 5 over 2 minus 5 over 2, which is 0. So for f inverse of x, you have this point. So do you see how these points have inverted? The x becomes the y becomes the x. What is the x? It is the input. What is the y? It is our output. And the inputs are becoming the outputs, and the outputs are becoming the inputs. This is what we call inverse. We're reversing, we're inverting, we're making an opposite function. We're making a function that does the opposite work. जैसे आपको कोई काम कहा जाता है ना, आप उल्टा काम करते हैं, तो that's what an inverse function is. So this was our graph. Now let's take a look at this. I told you that the line of reflection, these graphs are going to be reflected across the line y equals x. Okay, and the examiner asks for this in your paper in add maths. They asked about this a lot. They also ask about this in AS level, and so you have to memorize this because it's purely logical. Now you've got now we've got two functions here. We've got a function y equals x plus 3, and we've got a function y equals x minus 3. Well, if you've got x plus 3, iska ulta kya hoga? If you're adding 3, what would be its inverse? It would be x minus 3, right? Let me give you another example. We've got this beautiful drawing right here. Now, the first, operators that you learn in probably grade 1 is addition and subtraction. What are we doing? Those are called inverse operators. What are they doing? Adding something and then subtracting. They are the inverse of each other, and multiplying and multiplication and division, they are also inverses of each other. And so, as we look on their graphs, x plus 2, its inverse would be x minus 2. When we look at their graphs, they also have this line of symmetry, which is y equals x. A function and its inverse, when graphed on a plane, it will always have a line of symmetry, which will be y equals x. And you can take a look at this um, graph for 2x and x over 2, and it has the same line of symmetry, and it is the case with every function and its inverse. Now for these two functions, we're going to input some numbers in it. Let's input our number 1. We're going to get 1 plus 3, which is 4. Let's input the number 2. We'll get 5, because 2 plus 3 is 5. Let's input the number 5. We'll get 5 plus 3, which is 8. So our domain for this function in this question was 1, 2, and 5, because these were the numbers that I inputted. Okay, and what was the range? What was the outputs? We got 4 and 5 and 8. Okay, now 1 is mapped to 4, 2 is mapped to 5, 5 is mapped to 8. Now we want a function which maps 8 to 5, 5 to 2, 4 to 1. Okay, we want the inverse of that function. And now if we take a look at this function and we input these numbers, we input 4 into this, what are we going to get? 4 minus 3 is 1. If I input, let's say, 5, we're going to get 5 minus 3 is 2. If I input 8, what do I get? I get 5. And so our domain for this function is going to be the values that I inputted, which was 4, 5, and 8. And the range is going to be 1, 2, and 5 are outputs. And as you guys can already notice, that this domain just became the range of its inverse function, and this this range became this domain. Okay, the domain of a function is the range of its inverse function. I've written it down for you guys. You guys must understand this, that the domain of a function is the range of its inverse function, and the range of a function is the domain of its inverse function. Now, okay, now so I'll give you another example to cement your concepts. We've got this function which is a machine. Okay, we're inputting something and we're getting the output. This is our input, this is our function, this is our output. Now what did we make? We made a reverse machine. Okay, now what we're doing is we're taking these outputs, okay, and we're putting them inside this function, in this function. And so the outputs for this function is going to be the input for this function, and it is going to give us this output, which is going to be this value. And so you guys can understand from this is the inverse function. So as you guys can see that this output right here, we took this and input it into this function, and what we got out from the inverse function was the inputs for this function. Does that make sense? The domain of a function is the range of its inverse function, and similarly the range of a function is the domain of its inverse function. Okay, यहाँ पे domain was 1 comma 2 comma 5, and this became the range for its inverse function 1 2 and 5, and the range was 4 5 and 8 over here, and it became the domain for its inverse functions, right? So this was another important concept. Now now let's take a look at this graph right here. Now we've got a graph, we've got a function f of x equals x squared, and we've got its inverse. Well, if you're squaring x, what would its inverse be? What would its reverse process be if you're squaring something? Well, taking the square root is going to be its inverse, right? And so the inverse for this function is going to be the square root of x. Now I've drawn these two graphs. Now we notice two things here. There's this line of symmetry, which is y equals x, which is always going to be there, and it is not a complete reflection, is it? It is missing a part. Now where would it be if I reflected the whole thing? It would have been um, here. It would have been, let me use another color, it would have been here. Now I uh, did not show you this line. And why is that? Because we want an inverse function. It is its inverse, it is its reverse, but we want that reverse to be the to be a function, right? Now I made separate graphs for you guys to understand. This was our y equals x squared graph, and this was our y equals square root of x. And now if you guys see, okay, this is a function, this is a perfect function, but this what we have right here, this is not a function, because as you guys can see, uh, one input is having two outputs, right? What we discussed in our first video. So this is not going to be a function. And how do I get an inverse function out of it? Well, to get an inverse function, we'll just do what I did right here. I am gonna forget this part of the equation. I'm gonna forget this part of our function, so that I don't have to look at this. So what we're doing is we're basically restricting our domains. We're looking at this graph from this part, and this then now, since we restricted our domain, we've got our inverse as a function, because पहले भी inverse मिल गया था, लेकिन that inverse was not a function, because it was violating our definition, right? So now what we did was we basically took for y equals x squared, we basically took its domain. क्योंकि देखो इसकी actual domain is, if you guys look at it, is its actual domain is going to be all real values of x, right? Because you can input any value of x in it, and it's not going to give you any trouble value. But for this, to get an inverse, what we're doing is we're restricting the domain. We're just going to take the positive values, which is this. So what we actually did was we only took this, and if you invert this, you're gonna get this, which is a function. So sometimes we have to, there will be questions, we'll do those in the past paper session. There will be questions when the examiner asks you to, restrict the domain in such a way to to get a function which has an inverse. It will ask you when is an inverse possible, or uske liye you will have to restrict the domain. Now I took x as greater than or equal to 0, but I could also have taken x as less than or equal to 0, right? Because these are also functions. But what we do is, I'm sorry, 0. I've had to write 0 here. Now, but why did we take the positive values? Well, the reason for that is we like positive numbers, because numbers, they're basically mostly used for measurements, and you don't want to see a height equals a -5, right? You don't want to see this. You want to see a height that equals 5. You want to see positive numbers. Positive numbers are more important in daily life, and so we're just gonna take the positive sides of it. And there's a test for it. As we saw, there was a vertical line test for functions. There is a test which is called the horizontal line test, to check if a function has inverses or not. Now let's take a look at this. Now we'll apply a vertical line test for this, and this is our vertical line test. Now if it cuts at 2 points, right, this line is not going to have a inverse, right? It is cutting at 1 point in this graph, and so we are easily going to get its inverse. Okay, but if we look at this graph right here, we can see that this horizontal line cuts at 2 points, and so we're not going to have an inverse unless we restrict the domain. अब ये दो जगहों पे कट कर रहा है, तो why do we not have an inverse? Because if you invert it, if you take its inverse, the inverse तो आप निकाल लोगे, लेकिन that inverse is not going to be a function. वो कुछ इस तरह बन जाएगा, which is not a function because this is a straight line and it is cutting at 2 points. Okay, um, so that's basically it. Take care, guys. See you all in the next video. Bye bye.